Everyone, and welcome to your ultimate study session for GET 306. We are going to lock in absolutely everything you need to know about global energy systems so you can completely ace this material. I'm super thrilled to be your guide today. If you're looking for a highly efficient, focused explainer to get you 100% ready for test day, well, you're in the exact right place. So grab your notebooks, get comfortable, and let's translate these source materials into a crystal clear review. Let's dive in.
Okay, here's our quick roadmap for today's explainer. We'll cover 1. The global energy gap. 2. Flashcards fossil versus renewable. 3. The numbers for global and Nigeria. 4. Impacts of conventional energy. And finally, 5. An intro to solar. All right, section 1, the global energy gap. Let's set the stage with the absolute biggest problem facing the global energy scenario today. Grab your pens, because you'll definitely want to write this massive number down. Maybe put a big star next to it. Over 750 million people around the world currently lack access to electricity. Just think about that for a second. When we talk about renewable energy systems, we aren't just talking about upgrading our existing grids. We're literally talking about bringing power to nearly 1 billion people who are currently living completely in the dark. And notice the geographic concentration here. If you get a multiple choice question on where this energy poverty is concentrated, and you probably will, the answer is heavily in sub-Saharan Africa. Over 80% of those 750 million people live in this specific region. This really highlights exactly why finding local, sustainable energy solutions is an absolutely crucial piece of global development.
Moving right along to section 2, flashcards, fossil versus renewable. It's time for a rapid-fire round where we master the 2 most fundamental concepts in this course. First up, for your simple definitions, let's look at fossil fuels. Basically, these are formed from the remains of living organisms millions of years ago. The crucial thing to remember for the test is the mechanism of how we use them. Basically, they release heat energy when they're burned, and that specific heat energy is what we use to generate our electricity. It's a highly effective but very ancient process. You must memorize these 3 classic examples of fossil fuels: coal, oil, and natural gas. Seriously, write these down. Whenever the exam refers to conventional or non-renewable sources, these are the big 3 culprits the test is referencing. Now, grab a highlighter for this next definition. Renewable energy is energy derived from natural sources that are replenished at a higher rate than they are consumed. The absolute key distinction here, the whole shebang for your exam, is that rate of replenishment. We simply can't use them up faster than the Earth makes them. Keep these 5 examples of renewable energy sources handy for the exam as well. We've got solar, wind, hydropower, geothermal, and biomass or bioenergy. Notice the pattern here? All of these rely on natural, ongoing earthly processes like the sun shining, the wind blowing, or water flowing. Okay, section 3, the numbers, global and Nigeria. Let's see how this all builds into real-world data and understand just how reliant we currently are on those conventional sources. This is a guaranteed exam question, so lock it in right now. 59%. 59% of the world's electricity generation still comes from fossil fuels. And get this, within that 59%, coal is actually the highest contributor globally. So despite all the exciting talk of green energy, the vast majority of the world is still burning ancient organic matter just to keep the lights on. Zooming in on our case study of Nigeria, the numbers skew even higher. This brilliantly illustrates the local challenge. Look at this. Fossil fuels dominate the Nigerian grid at a whopping 77%, with hydrogeneration, which is a renewable source, making up just 18%. Now, there are other sources in the mix, like natural gas and some solar, but that 77% fossil fuel dominance,
That is the central statistic to remember. So, just to summarize the core differences for your notes, let's contrast them directly. Conventional sources have obviously been used for a long time, but they come with a lot of heavy baggage. They are mostly exhaustible, except for the water used in hydropower. They emit smoke and ash, causing pollution, and they are surprisingly expensive to maintain. Renewables, on the flip side, tackle these issues by naturally replenishing and drastically cutting down on those harmful emissions. Next up, Section 4, Impacts of Conventional Energy. This brings us to arguably the heaviest part of the syllabus, the major environmental consequences of relying on those non-renewable sources. A great study trick here is to group the impacts to make them way easier to remember. First, categorize the atmospheric impacts. Burning fossil fuels is the primary cause of climate change and global warming, largely due to massive carbon dioxide and methane emissions. On top of that, the combustion of pollutants like sulfur dioxide and nitrogen oxides, you'll see those as SOx and NOx on the test, are the direct sources of air pollution and acid rain. Next, let's chunk together the ground-level impacts. During oil drilling, vital water sources get contaminated, while soil nutrients are actively destroyed by heavy metal deposits left over from mining. And, of course, the exploration and extraction of crude oil carries the ever-present risk of massive oil spills, which devastatingly pollute both our oceans and our land. Finally, let's look at the broader ecosystem impacts. Oil exploration and mining require huge amounts of land, which directly leads to deforestation and the destruction of natural habitats. Extraction degrades sensitive areas like wetlands and drastically reduces biodiversity. And hey, remember this for the test. Even alternative conventional sources carry massive risks. Nuclear power poses huge waste disposal issues, and even large-scale hydropower can disrupt local ecosystems and displace entire human communities. All right, Section 5, Intro to Solar Energy. Phew! Take a deep breath. We have successfully covered the problems, the definitions, the data, and the environmental impacts. So let's quickly peek at the solution awaiting us in Module 2. In our next explainer session, we are officially leaving the fossil fuels behind and diving straight into solar energy systems. We'll be focusing specifically on understanding photovoltaic cells, modules, and arrays. We'll learn exactly how to design and size both standalone and grid-connected PV systems, and we'll even explore solar thermal systems used for heating and cooling. It's going to be a lot of fun. But to get your brain primed for that next section, I want to leave you with this one question to chew on. What are the physical principles behind how a PV cell actually converts raw sunlight into usable electricity? Like, how does it bypass the need to burn anything at all? Think about that. Definitely review your notes from today, and we will unpack that exact scientific magic next time. Keep studying hard, you've got this, and I'll see you in the next explainer.